in circles, so
you can see from the now that you're learning two different things today. They both seem like they're the same. It almost seems like you're writing the same thing. I have to read it sometimes. Recognize the 5 properties and inequalities to the measures of the angles of a triangle. So the first thing we're going to learn about is something talking about comparing angles in the diagram. Alright, so we're going to, I'm going to show you. Do we need to review what inequalities are? What's inequality? Like greater than or equal to less than. Different than an equation, because an equation is an exactly equal, right? So an inequality is just like less than, greater than, less than or equal to, greater than or equal to. Here's my trick for you. We used to say like that. In elementary school, they'd be like, the alligator eats the bigger number, right? But when you're not comparing numbers, you do that. So the less than sign kind of looks like an L, right? Since you see that that's like a slanted L. Less than looks like an L. All the properties of equations apply to inequalities, right? So you can add them to both sides, subtract them to both sides, transit properties. You can do all that stuff. You have to remember the one extra rule that you're solving inequalities together. Multiply and divide both sides like an aggregate. Only extra rule. If you graph inequalities, you shape x on y. We're not doing that. So we're going to look at comparing equals and inequality, and then what's the second one? We're going to the relationship between angles and sides. And this is something that's a really big deal. I kind of just forget that you don't know this one. So we can know about the angles of a triangle because the sides can be different. But let's compare angles, triangles, angles, and sides. Good, right? So since you have your book open there, I did not put that definition of inequality or the properties of inequality. I did not put that in notes because I just want you to know all the things in this equation are that means instead of like x equals 7, the only number, only begins with like x is greater than 7. Like infinitely numbers, right? So everything bigger than 7 numbers, there's an equation only. Okay, I know this didn't copy so well, but it's been a while, and this is all the stuff that we've learned about already, all the words. So I'm going to be quiet for a few minutes. I want you to look at your notes so you can flip back to the sections, and I want you to match up which ones go together, or if it's easier for you, you can label them like ABC, but I want you to take it to this and to look at those words. They're all contributing to the test of matching those up. Okay? Mine over here. Let me do this. I'm going to pause my video. Tamara, what do you think? Anything there? What could be using your notes? Or going back? Like 5.1 and 5.2 go in 2 sections. All these words come from those 2 sections, and they're highlighted in yellow. If you have your book open already, if you just flip that, you should see a word and be able to match it up with what it is. I started on this side and match like this. Like I read these and then I match them. We're gonna go. But know that on your test you could see something very similar to this. That you have to match things up. A lot of them came from the ones from last week. It's been a while, right? So I think we should just start with what to remember. Like I started, I'm gonna start with this side, and then we'll after it. Like a place where 3 or more intersecting lines meet. That's just like the vague word that's called the point where 3 or more lines, if they intersect in the same point, what's that called? The place where 3 or more intersecting lines meet. It's a point of concurrency. So the point of concurrency is saying that this one is the thing. And that just kind of jumping around doing the vague words. 3 or more lines that intersect at a common point, right? All of these words, when the medians all intersect and the altitudes all intersect, all of those we would call, in general, what? 3 or more lines, G. 3 or more lines that intersect at a common point would be which one of those words? G. 3 or more lines that intersect at a common point. Yeah, they're just in general, so you can't say medians, you can't say specifically, so concurrent lines. It's on mine, not on yours. The only other one that's really vague is the one right above that. A segment, line, or plane that intersects a segment at its midpoint and is perpendicular to the segment. Which one is that one? A segment, line, or plane that intersects a segment at its midpoint. A perpendicular bisector. We actually defined that a long time ago. So that's F. After that, they get really specific. So I don't know in which order you did this, but orthocenter and altitude, those are the ones that we learned last week. On Tuesday, those go together, right? So a segment of a triangle from a vertex that's perpendicular to the line containing the opposite side, that is the definition of an altitude. From the vertex, we just drew it in on that problem we did together. So let's go right together. And the orthocenter is where those altitudes meet, which I think is on there, right? The point of concurrency, where the altitudes meet, so that's the fourth one. And these are very similar definitions, which is why I thought this was worthwhile to go over today, especially after our break. So that's fun. Anybody got another one they want to use? In-center and circumcenter, those are always, I don't know why, I guess because they both have the word center in them. Those are always hard ones for me to do. In-center, is that the medians or is that the perpendicular bisector? The point of concurrency of the medians of a triangle. Medians is incident. And then the perpendicular bisector is that's not right, is it? this one. Did you see that one? A segment with the vertex of a triangle and the midpoint of the opposite side. That's the definition of median. My numbers are all getting messed up. Is that E and 6? What's the other one that we learned on Friday? The centroid? Wasn't the centroid the median? I think I disagree with this. This is not what I had. I thought it was the centroid is the point of concurrency of the median. Okay, let's make it sure. Which is what I had. Which means all we're left, I think, are circumcenter and incenter. One of them is perpendicular bisectors, one of them is angle bisectors. So that's the other thing I think that I get confused with. But I believe perpendicular bisectors are circumcenter, angle bisectors are incenter. So that means that these two go together. Nope, just kidding. These two go together. So 4I. Yes. So this one's H. It's kind of tough, right? It seemed like a simple thing, but you got to keep it all straight. And it's even tougher because I had to like write my numbers and my letters together. Very similar words. Remember I told you that you get to use a sheet of paper to write theorems down, and all the theorems have those words in them. Very helpful, but you still got to be able to go through it and match stuff up and know which one you're talking about. Very easy to mix those up. So you want to make sure that we kind of keep reviewing that. Just because you get to use a piece of paper doesn't mean you still have to kind of be aware of it, because you only have one class period to take a test, so you can't spend an hour sorting through all that stuff that you wrote down as you do that. Okay? Okay, the good news is that today's stuff isn't that bad. There's like two things over in the now part. The first one is the exterior angle inequality theorem. And again, instead of me writing it out for you, it's there. We can kind of write it out together. But it says, describe the exterior angle inequality theorem in your own words, and then use the figure to write two inequalities. So again, we're going to use our book to show you that your book can help you. Look on page 342. It should be at the top of the next page. The exterior angle inequality theorem. Read that. Look at it. And see if you can kind of make this up. If you want to write it word for word, you can. But read it to yourself there. And see if you can make sense of what it's telling you. Eaten by is greater than the other. Measure of angle 1 is greater than, and the measure of angle 1 is greater than. You're confusing that angle 1 is greater than. A and B. So it's greater than these other two angles. Angle A. Should I say angle A? So your book uses corresponding interior angles. I would say the measure of an exterior angle is bigger than the two non-adjacent interior angles, right? Like not the one right next to it, but the two non-adjacent, or you could use the words they use. So I'm going to write it in my own words. The measure of an exterior angle is greater than either non-adjacent. theorem's really easy to prove because we have a theorem that says the exterior angle is actually equal to what? Do you remember that theorem from the last chapter? That angle 1 is equal to A plus B, right? So if that's true, doesn't it make sense that either one of those angles by themselves has to be smaller than angle 1? So that's where that theorem comes from. So that's where that theorem comes from. There's actually little proofs to go with it if you wanted to use it, but it's easy to prove that theorem because we know angle 1 actually equals angle A plus B. So either one of them by themselves have to be smaller than that. What kind of problems are they going to give you? They look a little confusing, I think, because there's a whole lot of stuff going on. So look at this picture. So they give you this picture with all these numbered angles, and I have two parts here, so let's look at part A first. It says, use that theorem to list all angles that are less than angle 14. All angles that are less than angle 14. So here's angle 14, that's my exterior angle. So if we use this triangle right here, right, like angle 5 would be the one right next to it, what would be the two angles that we would say have to be less than angle 14 in that same triangle? 4 and 11, because 4 and 11 should add up to give me 14, does that make sense? So I could say, I know for sure, angle 11 and angle 4. Anybody give me a reason why we should add some more angles there? Eight because it's congruent to 4. Because you're one to say like alternate interior angles. Yeah. No, are they parallel? It doesn't say it's a parallelogram, right? To me, this triangle doesn't look the same as this triangle. Do you agree with me on that? And I know we're not supposed to say just looks like, right? But if we're saying it's a parallelogram because it looks like a parallelogram, I'm saying it doesn't look like a parallelogram because I don't think that top line is parallel to that line. You see what I'm saying? Like, it's not marked parallel. We're not going to say it's parallel. But I do, someone said 9. Why can we say 9 for sure? Vertical angles has to be true, right? So we can say angle 9. What else someone said? I want to... Yeah, that's it. Well, but it is corresponding, but I feel, I don't know. They're not parallelized, so you can't say because corresponding angles are parallelized. You can't say that. I know that, right? You're the one that looks. And look, it's not parallel. Oh, kids. And that means that why would I say that I did?
Well, because 14's like this, and 5's like this, so we can pretty much strip the 5.
Yeah, let's do it. Because using the exterior. Taking this now.
5 is obviously smaller than 11, right?
It doesn't have to be to scale, right?
But you know that 5 is going to be smaller than 11, right? 11 is smaller than 14. Right?
With the wrong drawings. Alright, let's look at part B. I'm going to come back. There's actually other angles. The book answer does not include 5, but it does include other angles. It doesn't
What
include.
other angles?
It says 4, 11, 9. Got those. And it says 3, 2, 6, 7.
Oh, I see where it's at.
So now, if 11 is the exterior angle, right? And we already know that 11 is less than 14. So now if 11 is the exterior angle, wouldn't it be the exterior angle in this triangle? So now 6 and 7 would be the two angles that are less than 11. And since 14 is less than 11, 11 is less than 14, then these are less than 11, which are less than 14 as well. So could we do the same thing with 2 and 3? Would 11 be the exterior angle for 2 and 3 also? Oh my gosh, all right, that was good. That was like some good transitive stuff. Okay. Let's think about part B now. Now it's going the other way. So now it says, use the angle theorem to tell all angles that are bigger than angle 5. So now we want everything bigger than angle 5. So mostly we want to look at like exterior angles from that. Do you agree with that? So what would be the exterior angle that could go with angle 5? Could angle 10 be an exterior angle that would be with angle 5? Definitely 10 and 12, I think.
I feel like
Why is there
everything is.
We aren't just looking at the size of the angle. We're looking at the exterior angle theorem and then any vertical angles. Other than that, we can't use corresponding, we can't use alternate interior, because we don't know that these are parallel lines, and we can only say those are congruent if we have parallel lines.
what is the number of angles that's with 14?
Is there another angle there? Oh, sorry.
Well, then where's 13? Where's 13?
There's no 13. So do you think those outside angles should be included? Would 17 be an outside angle for that try for 5? Yeah. So 17 is included. I'm using Audrey's logic now. If 10 is bigger than 5, what angle could be an outside angle for angle 10? So if 10 is bigger than 5 and 16 is bigger than 10, then 16 has to go here too. Right? Like that kind of hurts my brain a little bit. Same thing with 12. If 12 is bigger than 5, what's an outside angle for 12?
Wow.
Which is why we're doing this together. I don't know. Maybe. Yes, I think so. So we'll try and see. But that's the idea. So you have to use like the transitive property to get there. Okay. Good. Okay, I don't know if we've actually talked about this. We talked about in an isosceles triangle. In an isosceles triangle, if the sides are the same, the angles are the same. Or if the angles are the same, the sides are the same. Well, you can actually make a relationship with all the sides and the angles in a triangle. So, it says, if one side of a triangle is longer than another side, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. Did you know that was true? Like, the longer a side is, the bigger the angle is across from it. Think about in a right triangle. What's the biggest angle in a right triangle every time? The right one. And which side is the longest in a right triangle always? The hypotenuse, which is opposite the angle. So that's always true. Not just in right triangles, but in every triangle. So it says, if xy is bigger than yz, so 9 is bigger than 7, we can say we know the angle across from it is bigger than the angle across from the shorter side, which means you kind of have to draw on your picture sometimes to see that. And it just says the reverse of that is also true. Chandler, if you know an angle is bigger than another angle, then the side across from the bigger angle will always have the longer side length. So the longer the side goes with the bigger the angle. The smallest side goes with the smallest angle. Always. Isn't that kind of cool? Which means this is not nearly as confusing as the other thing that we did. If I gave you a picture with all the sides of a triangle and I didn't have any angles labeled, we can put the angles in order from least to greatest or greatest to least by just looking at the side lengths. Does that make sense? So, if I gave you this lovely triangle, LMN, and these are the side lengths, which angle is the smallest angle? Yeah, and make sure you don't get confused there. You got to go from the side to the one across the street. It's not bad, except for if it's not drawn to scale, but it's labeled on the outside, right? Or if they're really close together, you might not be able to tell. So angle L would be the smallest, and then what would be the next smallest? N, because 10.2 is the next side, and N is across from that side, so then angle N. And then the biggest side is always across from the biggest angle, which in this case would be angle N. Really cool to know that. I forget that that's not something that you know. So the same thing if I went the other way. If I gave you the angles in a triangle now, you can now tell me which is the shortest side, the middle side, and the longest side by just looking at the shorter side goes with the smallest angle, the biggest angle goes with the biggest side. So remember when we name sides, we need to give it 2 letters, right? So if you didn't know this rule, like between the 45 and the 55, actually they really kind of all look the same, right? But because we know this, what's the shortest side? Yeah, the side across from 45, which would be side AC. Oh no, it's just wrong. And so then our middle side would be AB. And then the longest side is always across from the biggest angle, which in this case would be BC. This is something that we use all the time, especially when we do trig and pre-cal. Really important for breaking sides of the triangle. You know a lot of that, so that's the shorter side. So it's something that I have forgotten that you don't always know. Alright, so what's the last thing here? Making you think. Helping you remember, actually. I shouldn't say making you think. It says, explain how the exterior angle inequality is related to the exterior angle theorem, and why the exterior angle inequality theorem must be true. Oh, we already said this. The exterior angle inequality is the new thing that we said, where we said, if I have this, you just throw your down. We should laugh. Like, we should probably check that it's okay and say sorry. More than just laugh and say, no big deal, it's just
There was no
great.
allergy. It was a prank.
Sorry. Not say sorry to the Chromebook. Say sorry to me. Because I'm going to be the one that gets in trouble if the next person that opens that is broken.
No, then you just blame it on the person. You and Alex.
It was the classroom. Oh. It was part of the thing.
So the exterior angle inequality is what we just learned. The exterior angle theorem is what we talked about. We kind of did this already. I forgot this was what's in. The exterior angle theorem says that the measure of angle 1 is equal to what? The exterior angle is equal to the sum of the other ones. So the measure of angle A plus the measure of angle B. Those are the two theorems. This says, why does the inequality thing have to be true if you know this is true? What do you, I need more. Someone help her out. She says, if it adds up to 1, then it can't be greater than that. I want more. What does that mean? I know it makes sense. I just need you to put it in words. Say, if this is true, the question is, if this is true, if you know angle 1 equals angle A plus angle B, how does that make this inequality statement true, that angle 1 is bigger than angle A, and that angle 1 is bigger than angle B? Because angle A and angle B have to be smaller than angle 1 itself if they add up to equal that, right? Like that's kind of like almost like the proof of it. It's saying that if two angles add up to equal one angle, then separately the two angles can't be bigger than it, right? That's kind of what they're wanting you to say there. You can almost make that your proof of that theorem, all right? So kind of what we talked about earlier, but it's just kind of putting it there as well. Prove it. I'm not going to write that. You must write it. So here is your homework. Homework 5.3. I'm going to look at the calendar and see. I don't know. I might change that, and we might have a quiz at one point this week, but I'd like to be able to review Friday, probably review Monday, test Tuesday, corrections Wednesday, start reviewing for final Thursday. Yeah, we just have this week and next week, and then, like, usually I give 3 days review for final, which means we need to make sure we start reviewing by Monday. That would give us Friday, Monday, Tuesdays. But you guys have me 4th hour, and usually 4th hour final is until the last day, so we have extra time next week. So we might do this a little bit.